Hello students, in today's video session I am going to explain you about the excellent trick to remember the order of minus I effect. Minus I effect and plus I effect both are the types of the inductive effect. In turn, inductive effect is a type of electron displacement effect. There are basically five types of the electron displacement effects. Number one is inductive effect, number two is a mesomeric effect or a resonance effect, number three is the hyperconjugation, and number four is electromeric effect, and fifth is a inductomeric effect, etc. Out of that, the first three effects are the permanent effects and the last two effects are the temporary effects that we discussed earlier in the previous video sessions, right? So in the previous session I discussed about the plus I effect also. Plus I effect means what? The groups which donate electrons to the other, right? The electron donating groups are called as a plus I groups and electron withdrawing groups are called as a minus I groups, right? Electron donating groups are plus I group. Plus I group means they show plus I effect. Plus I effect means they show positive inductive effect, right? Positive inductive effect and negative inductive effect are the two types of inductive effects, right? That we call it as a plus I effect and minus I effect. Okay, so in the last previous video session, we discussed about the plus I effect, that is the positive inductive effect. Positive inductive effect means the groups which donate electron, which repel electron from itself. Okay, these groups are called as a plus I groups and they show the positive inductive effect, that is the plus I effect. All alkyl groups, generally all alkyl groups show plus I effect. Some exceptions are there. One of the exception is a Grignard's reagent. In Grignard's reagent, alkyl group is there. Okay, RMgX, Mg is a metal, R is alkyl group. In that case, metal donates electrons so that the alkyl group may acquire delta negative charge, and in that particular case, the alkyl group may act as a minus I group. It will show minus I effect in that particular example, but otherwise in most of the cases all the alkyl groups are plus I groups, right? All alkyl groups are plus I groups. Otherwise some exceptions are also there. So we discussed about that plus I effect in the previous session. Now in today's session I am going to explain you about the excellent trick to remember the order of the minus I group. I will take first some examples. I will explain you about that examples, and then I will give you the order for that, right? So see here, this is the first example. Minus I effect, the first example. Here NF3 is the first example. Now here NF3 plus, it is a example, NF3 plus. So here fluorine is more electronegative than that of the nitrogen, that we know. Fluorine is more electronegative, and so that fluorine may withdraw electron from the nitrogen. This fluorine also withdraw electron from the nitrogen, and this fluorine also withdraw electron from the nitrogen. And so the nitrogen will acquire delta positive charge, etc. So this nitrogen becomes again electron deficient, and in turn this will withdraw electron from this side. This nitrogen will withdraw electron from this side, and that's why this group, that is the NF3 group, it will show minus I effect, right? It will show minus I effect. Now here in this example, this nitrogen NR3, this is a particular example, that is a NR3. R means any alkyl group. R means any alkyl group, right? Here methyl groups are taken here. Now you know that, now I told you now that the alkyl groups, they donate electrons, right? Alkyl groups are electron donating groups. They show plus I effect, right? And hydrogen will not donate electron, will not accept electron. It will not show any plus I or minus I effect. So as this fluorine is electronegativity of fluorine is more than that of the nitrogen, so that the fluorine will withdraw electron from the nitrogen, and nitrogen becomes very electron deficient, and it will again withdraw electron from the other side, that is any other group of the compound is there. And so here as we know that the alkyl groups are electron donating groups. Now these are the electron donating groups, so that the nitrogen will acquire minus delta charge, minus delta, partial delta negative charges will be formed on the nitrogen, and so that there is a less tendency of nitrogen to withdraw the electron. There is a less tendency to withdraw the electron as compared to the NF3. As compared to the NF3, this NR3 group has a less tendency to withdraw the electron. Now, these hydrogens, NH3 example, the hydrogens will not withdraw or donate electrons. Actually, the position of this NH3 group will be in between the most electronegative and this electron donating group. Means the position of this NH3 group, it should be here in between the NF3 and NH3. Why? Because here F is a more electronegative, it withdraws electron, it will show minus I effect, and this methyl groups, these are the electron donating groups, but this is the intermediate, it will not withdraw, it will not donate electron. That's why this species actually is in between these two species, two compounds, but it is not happened. It will show again less minus I effect. What is the reason? That I am going to explain you. What is the concept behind this? Now let us see here the concept, right? Yeah, concept. Now here these concepts will help us to remember the order. Okay, here CH triple bond CH means hybridization is sp hybridization. sp hybridization means bond angle is 180 degree, and the percentage of S character is 50. That we already discussed. Percentage of S character in sp hybridization is 50%. Here CH2 double bond CH2 hybridization is sp2. Bond angle is 120 degree, and so the S character means S character in sp2 1 divided by 3 into 100, it will become 33.3% of S character in this case. And in the third case, CH3 means it is an example of ethane, right? It is ethane, and hybridization is sp3 hybridization. Bond angle is 109 degree 28 minute, and percentage of S character is a 25% S character. Now what will happen here as we move here from top to bottom? The bond angle going to increase here. Bond angle increases 109 degree 28 minute to 120 degree to 180 degree. Means here bond angle increases as the percentage of S character increases. See here is the percentage of S character only 25%. Here 33.3%. Here 50%. Means here hybridization changes from sp3, sp2 to sp hybridization, and bond angle decreases 109 to 120 degree to 180 degree, like this. But means the bond angle increases. Bond angle is directly proportional to the percentage of S character here, right? Bond angle increases. Percentage of S character also increases. It will increase from 25 to 50, right? The bond angle increases means bond angle is directly proportional to the percentage of S character. Bond angle is directly proportional to the percentage of S character, and percentage of S character is directly proportional to the electronegativity. Now this the sp carbons are having more electronegativity than sp2 carbon than sp3 carbon. Means these CH triple bond CH, this sp carbon, both carbons are sp carbons, okay, sp hybridized carbons, and these are more electronegative than this, and these are more electronegative than this. Means sp hybrid carbons are more electronegative, means the bond angle is directly proportional to the S character. S character is directly proportional to the electronegativity, right? S character here increases. More is the S character, more is the electronegativity. Less is the S character, less is the electronegativity. Here S character is only 25%. Here S character is 50%. The electronegativity of this ethane is less as compared to the acetylene or ethylene, right? Electronegativity of this compound is greater than this. Means the S character increases, electronegativity will also increases. In short, bond angle is directly proportional to the percentage of S character. Percentage of S character is directly proportional to the electronegativity of the atom, directly proportional to the minus I effect, right? Electronegativity is directly proportional to the minus I effect. Means we know that here we are discussing about the minus I effect, means the groups which withdraw electron are called as a minus I groups, and these groups are showing the minus I effect, right? Now this electron withdrawing capacity depends upon the electronegativity. More electronegative atom will withdraw more electrons more powerfully. Okay, means electronegativity is more, minus I effect is also more. Electronegativity is less, then minus I effect is also less. Now this is the concept behind this. Now I will explain here why the electronegativity of this Nr3 group is in between this NF3 and NH3, right? Now this I am going to explain you. Now here these groups, no doubt these groups are the electron donating groups, right? These groups are the electron donating groups, and so that its position must be here beyond the NH3, but it is not like that. What is the reason? Reason is that here there are the 3 methyl groups, and these groups are having a larger size. Okay, so there is a repulsion between the methyl group and methyl group. There is a repulsion may create here. There is a repulsion. Why? Because these groups are larger groups. These groups are bulky groups, and so that the repulsion will take place. And due to repulsion, what happens? Due to repulsion, the bond angle increases. Due to repulsion, bond angle increases. Actually, its bond angle must be 109 degree 28 minute, but it is not so. Its bond angle may increase due to the repulsion. Due to the repulsion, the bond angle increases, and if the bond angle increases, see here, bond angle increases means the S character increases. S character increases means electronegativity increases. Electronegativity increases means minus I effect also increases. So this group shows greater minus I effect than this group. Nr3, this is Nr3 and this is NH3, right? In between the Nr3 and NH3, which group will show stronger minus I effect? Nr3 will show the minus I effect more than that of the NH3. What is the reason? Reason is that the repulsion between the larger groups, the methyl groups are electron donating groups, okay? But here as compared to the NF3, these groups show less minus I effect, but as compared to NH3, these are showing more minus I effect. The reason is bond angle. Bond angle increases, the S character increases. S character increases, electronegativity increases, and electronegativity increases means the minus I effect also increases, and this is the order for the minus I effect in the first example, right? Now we will see about the second example. In second example here, NO2 group is there, then cyanide, that is a C triple bond N, and COOH acid group is there. Now here this carbon is a sp carbon, this carbon is a sp2 carbon, and this carbon is also sp2 carbon. Now according to our concept, the sp carbon, sp carbon means more percentage of S, right? More S percentage of S character, and so that it will have larger bond angle, and it will show more electronegativity, and it will show in turn minus I effect more as compared to this also, but it will not happen in this example. This is a twisted example. You have to remember this example. NO2 has more order, right? NO2, then Cn, and then COOH, etc. Why? Because here both the atoms, that is the nitrogen as well as oxygen, both are the electron withdrawing groups, right? All these atoms are the electron withdrawing groups, right? And here only nitrogen is the electron withdrawing group atom, and carbon is in turn it will also withdraw electron. But here the overall effect of the minus I effect for NO2 group is larger than that of the Cn. And here as we compare the Cn and COOH, then it is a sp hybridized carbon and it is a sp2 hybridized carbon, right? So it will show more minus I effect as compared to the COOH, means sp will show more than that of the sp2. But this is an exception, and that you have to remember in this second example. NO2 group shows minus I effect more than that of the CN will show more than that of the COOH group, right? Now third sequence here: fluorine, chlorine, bromine and iodine. Fluorine, chlorine, bromine and iodine. These are the atoms which are present in the halogen family, and in the halogen family from top to bottom the electronegativity decreases and atomic size increases, right? So electronegativity decreases in the same order, and as electronegativity decreases, minus I effect also decreases, that we know already, right? Electronegativity of atom directly proportional to minus I effect. More is the electronegativity, more is the minus I effect. Less is the electronegativity, less is the minus I effect. This is the series. This is the sequence of the order of the minus I effect regarding these particular atoms which are belonging to the halogen family. Now coming to the fourth example, these three examples we explained. Now this is the fourth example. In fourth example, what happens here? Now see the hybridization here. Carbon triple bond is there. Okay, means how to identify hybridization, that you know already. Here how many bonds are there? 1 sigma bond and 2 pi bonds are there right now. So its hybridization is sp hybridization. Its hybridization is sp hybridization. Okay, because carbon is linked with only 2 sigma bonds, one towards this carbon and another towards this hydrogen, right? This carbon also linked with this carbon with 1 sigma bond and another with 1 sigma bond. So only 2 sigma bonds are there involved in the hybridization, so that the hybridization is a sp hybridization, right? Now here, which type of phenyl? pH. pH means phenyl group. Phenyl group means I have drawn here. I have the phenyl group, the structure for the phenyl group. Here each carbon of this phenyl group is sp2 hybridized. It is a sp2 hybridized carbon atom, right? So as compared to the sp hybridization, sp2 hybridization is a less electronegative. This is a concept. You can see once again this concept. More is the S character, more is the bond angle, more is the bond angle, more is the S character, more is the S character, more is the electronegativity, and if more is the electronegativity, more is the minus I effect. So that this compound is it will show more minus I effect as compared to this. And again this compound, in this compound both the carbon atoms are sp2 hybridized. Here also all carbons are sp2 hybridized. In phenyl group, pH it is denoted by symbol pH. It is a phenyl group. The structural formula for this is that much. And here the alkene group, CH double bond CH2, alkene group, here both the carbon atoms are again sp2. Here also sp2. But why the electronegativity of this group is larger than this? Why this group will show minus I effect more than that of this group? The reason is that here more number of sp2 hybrid carbons are there, right? And here only 2 are present. Here only 2 numbers of carbons which bear the sp2 hybridization, right? This group will show maximum more minus I effect than that this group, right? This group will show more minus I effect than this group, and this group will show more minus I effect than this group because this carbon is sp hybridized, right? Sp hybridized means bond angle is 180, right? Bond angle directly proportional to S character. S character directly proportional to electronegativity. Electronegativity directly proportional to minus I effect. That's why here hybridization is sp hybridization. Bond angle is 180, right? Bond angle is 180 means here more electronegative atom is here, okay, and so that it will show minus I effect more. And this there is hybridization is sp2. Bond angle is 120, right? And it will directly proportional to the S character. S character is directly proportional to the electronegativity. In turn is directly proportional to the minus I effect. This is the order for this. What is the reason between these two? More number of sp2 carbons are here. Here only 2 sp2 carbons are there. That's why this group will show maximum, that is more minus I effect as compared to this, right? Now fifth example, coming to the fifth example, here fluorine is more electronegative, right, than oxygen. Oxygen is more electronegative than nitrogen. That's why this is the order for the minus I effect also. More is the electronegativity, more is the minus I effect. More is the electronegativity, more is the minus I effect. And here the electronegativity decreases in this order, minus I effect also decreases in this order. These all are the 5 examples. The concept behind these examples is this. This is an important concept, right? Now if we combine all these 5 examples, 1, 2, 3, 4, to remember all these groups in a very correct manner, it becomes very difficult to remember all these groups. So that's why I make this video to remember in a very easiest way. 1, 2, 3, 4, 5 examples are there. Now overall order. Example, you take example number 1 first, right? Example number 1 means all the groups which are 3 in number in the first, right? Here number 1 NF3, then NR3, right? NR3 means NCH3 taken thrice, right? R means any alkyl group, NCH3 thrice. Then the third, that is NH3, here NH3. Then coming to the second after 1. Now take second example. In second, how many groups are there? 1, 2, 3 groups are there in second. So try now this NO2 after NO2 Cl, that is a nitrile or cyanide. Then the COOH group, right? Now coming to the third example. Third example starts from here. Third example, one example, second, third, fourth and fifth. Okay, these are arranged in the decreasing order. First you try to understand each and every example in detail. Okay, first example, second, third, fourth, fifth. In each example I have given 3 or 4 examples. That's why you have to remember in that way. And so that here next third number of example comes from here. Then fluorine, see here, fluorine, chlorine, bromine and iodine. Then coming to the fourth now. Here fourth first is C triple bond CH, that is acetylene group, and here phenyl group, then alkene, and then after alkene here, after alkene this fluorine and this, then OH and NH2, right? NH2. Now this is the order of the minus I effect, the groups showing the minus I effect. This is the correct order, and I hope it will become very useful for you to remember this order. And if you like this video, like it, subscribe it. It will motivate me, and I will make more and more videos for you. So thanks for watching, and have a nice day. Bye bye.